Imagine a glitch in your brain that hijacks your senses, a lightning-fast error in your own internal wiring that turns something harmless into a monster before you can even consciously process what's happening. One moment you see a spider on the wall, the next your heart is pounding, your palms are sweating, and your entire body is screaming, "Danger," all in a fraction of a second. This isn't just being scared. This is a neurological short circuit, a biological override that creates your most irrational and visceral terrors. This is a phobia, and today we're going to explore the creepy science behind why this happens, how your brain builds these prisons of fear, and whether you can ever truly escape them. So, what's the difference between a healthy fear and a phobia? Well, fear is a vital survival instinct. If you're hiking and see a bear, your fear response is perfectly rational. But if you have a panic attack because you see a cartoon drawing of a bear, that's leaning into phobia territory. A true phobia is a fear that's wildly out of proportion to the actual danger, is persistent for 6 months or more, and significantly messes with your daily life. The source of this overreaction lies deep within our brain, in a small, almond-shaped cluster of neurons called the amygdala. The amygdala is our brain's ancient, primal fear center. It acts as an early warning system, constantly scanning for threats, and it operates on 2 distinct pathways. Think of it like this. The first is the slow path. When you see something, say a garden hose coiled on the lawn, the information travels from your eyes to your thalamus, which is the brain's sensory relay station, and then up to the prefrontal cortex. This is the thinking part of your brain. It analyzes the info and concludes, okay, that's just a hose, no danger here. It then sends a message to the amygdala, telling it to stand down. But there's also a fast path, a neurological shortcut that phobias exploit. Here, the information zips from the thalamus straight to the amygdala, completely bypassing the conscious, rational cortex. This is the short circuit. In mere milliseconds, before your thinking brain even has a chance to catch up, the amygdala sounds the alarm and triggers the fight-or-flight response. Your body is flooded with adrenaline, your heart races, and you react with pure, unthinking terror. In people with phobias, this fast pathway is hyperactive, turning a simple stimulus into an immediate, overwhelming threat. So where do these glitches, these hypersensitive fear circuits, actually come from? Scientists believe they develop in a couple of primary ways. Some fears we are prepared to have, while others are learned from experience. Let's start with what scientists call prepared phobias. These aren't strictly innate, but they are fears that evolution has primed us to develop very easily because they were helpful to our ancestors' survival. Take nyctophobia, the fear of darkness. While fear of the dark is a normal developmental stage for kids, for some, it becomes a lifelong phobia. This is likely an evolutionary ghost, a leftover survival instinct from a time when darkness meant a higher risk of predators. For most people, this fear fades with safe experiences. But in some, due to genetic or developmental factors, the amygdala's alarm bells never learn to quiet down. Then there are the experiential or learned phobias. These are often forged in the fire of a single powerful event. Imagine being at a childhood birthday party. Suddenly, a balloon pops with an explosive bang right next to your ear. The shock, the sound, the surprise. It's an intense moment of fear. Your brain is designed to remember that, to protect you in the future. This memory gets cemented in the amygdala, essentially strengthening the neural connections associated with that fear. Now, a harmless balloon is no longer just a balloon. It has become a conditioned trigger for panic. This is globophobia, the fear of balloons. And for those who have it, every balloon becomes a ticking time bomb, forever linked to that initial traumatic sound. The brain's ability to create fear isn't just limited to ancient threats like darkness or sudden noises. That short circuit in the amygdala can turn the most bizarre and mundane things into sources of profound horror. It's here that the science of phobias gets truly creepy. Take trypophobia, the aversion to clusters of small holes. For people with this condition, looking at a honeycomb, a lotus seed pod, or even bubbles in coffee can trigger intense revulsion and anxiety. Leading theories suggest this is another evolutionary echo. These patterns share visual characteristics with things that were genuinely dangerous to our ancestors, like the skin of venomous animals or the appearance of diseased tissue and parasites. While a non-phobic person's conscious brain can easily dismiss a sponge as harmless, the trypophobic brain's hyperactive fast path screams disease or danger before the cortex can intervene. Or consider something even stranger, arachibutyrophobia, the fear of peanut butter sticking to the roof of your mouth. It sounds almost comical, but for sufferers, it's a terrifying sensation often linked to primal fears of choking or suffocation. That sticky texture is thought to trigger a sensory-based panic, a direct activation of the amygdala's most basic survival alarms. This fear can stem from a past traumatic choking incident, but it can also exist without a clear origin. Then there's phobia, the fear of mirrors. This isn't just superstition, it can tap into a deep-seated part of the brain responsible for self-recognition. For someone with this phobia, their own reflection can be perceived by the amygdala as an intruder staring back. That flicker of movement in the mirror isn't them, it's something else. This hijacks the brain's intruder detection system, sparking a terrifying confrontation with a distorted version of oneself. It's astonishing how many people live with these glitches. Studies estimate that up to 12.5% of adults in the US will experience a specific phobia at some point in their lives. You are not alone in your irrational fears. These phobias aren't a sign of weakness, they're a testament to how ancient survival hardware can misfire in our modern world. So if your brain is short-circuiting and trapping you in a cycle of fear, are you just stuck with it forever? The answer, thankfully, is no. Because fear responses are often learned and reinforced, they can, in a sense, be retrained. Treatments for phobias are all about retraining the brain and rewiring these faulty circuits. The gold standard is exposure therapy, which is a form of cognitive behavioral therapy, or CBT. The goal here is to create new, safe memories to compete with the old, fearful ones. It works by gradually and repeatedly exposing a person to their phobic trigger in a controlled environment. If you're afraid of snakes, a therapist might start by having you just read about them, then look at pictures, then watch a video, and eventually be in the same room as a snake in a tank. Each step is small and manageable. With each successful exposure where nothing bad happens, you are actively teaching the amygdala that it doesn't need to scream danger every time. You're weakening the fear pathway and strengthening a new safe one. CBT also works on the slow path, that thinking part of the brain. It helps you identify the irrational thoughts fueling the phobia, like "this elevator will definitely crash," and replace them with more rational ones based on evidence like "flying is statistically one of the safest ways to travel." By strengthening the prefrontal cortex's ability to reason, you give it more power to override the amygdala's initial knee-jerk panic. In recent years, therapists have even started using virtual reality for exposure therapy. This allows people to confront fears of flying, heights, or crowded spaces in a completely safe, simulated environment, showing that the brain can be retrained even without the physical threat. It's the experience of safety in the face of the trigger that rewires the connection. Phobias give us a fascinating, if terrifying, window into the architecture of our own minds. They reveal a constant battle between our ancient instinctual brain and our modern rational one. That feeling of irrational terror is a glitch, a short circuit where an ancient alarm system designed to save us from predators misfires at harmless objects. It's a powerful reminder that deep within our sophisticated brains there is still a primal machine running on ancient code. So the next time you feel that illogical panic or that unshakable dread, remember what's happening. It's not a character flaw or a sign of weakness. It is a creepy and deeply human glimpse into the complex and sometimes chaotic wiring that makes us who we are. If you learned something new about the weird wiring of your own brain, hit that like button and subscribe for more deep dives into the science of the human mind. And now, I have to ask, what's your phobia? Let us know in the comments below. Reading through them, you'll see you are definitely not alone.